And we are live. So today, like I mentioned, we're gonna be redoing the AR Lego game. We're gonna be starting from scratch. The reason is last time we recorded this, I had some sound issues, so we're gonna go ahead and just do the first episode again, but not the same topic we've covered. We're gonna be covering really AR stuff today. In fact, with the preview screen, you saw this icon here. This icon here is something I've made a little bit earlier actually, and I've printed it out. It's right here. This is going to be my target. So when you look far away with your phone or with your webcam in this case, and you see that in the real world, this is what is going to tell our AR plugin to just, this is a object we're tracking. And when you make an object like this, when you make an image like that, really make sure you have a lot of sharp edges and a lot of different contrasts. Right here I only have two colors, I have black and white. It works perfectly fine though, because I have a lot of sharp edges. And there's like no pattern, you can't like do a symmetry with that. So this is one of the good images you can use for tracking. And most likely going to have this somewhere in the description if you just want to grab this image, simple PNG, or create your own. It really takes a second. And you print it out. I have a few copies here, I'll just bring out of this paper. I originally planned to just make a image with the pencil and try to track that. It's not as easy as it sounds. Okay, got my copy. This is gonna be my target, and we're gonna jump right into making this Unity game. If you guys have any question during the live stream, you can always ask. The chat is there as well. I think it's on the live stream right now. Yep. I'm going to leave it on. And let's go ahead and just start a new project. AR Lego. It's gonna be the same exact thing, but I'll just name this one new, or I'll type in Augmented Reality. So same thing as last time, we're gonna head over to the Vuforia and also get their plugin. Sign up if you don't already have an account. You should have an account by then. So let's go into Vuforia. And then at this point, we are going to head over to the tool and resources, click on tool and resources, and we are going to download for Unity the SDK. Now, you obviously have to create an account for this. They keep track of your images, they keep track of your information in the plugin. So simply going to download this thing. Once it's done, we are going to need a database. And hello, I am programmer. Welcome to the stream. Like I said, we're gonna need some kind of database on top of that, but before going into the database, let's just make sure we instantiate this. So I'm going to click on my Unity package. It's going to import right inside of the actual engine. And let's see. We need the plugin, yep, that's for sure. We need Vuforia. And is there any kind of demo in here? Doesn't seem like there is any demo, so we're simply going to import everything. And of course, we're gonna need a few settings in here to make sure it works. Now, we are going to need, let's just say that this is our game scene, save this as a game scene. We're not going to be using a standard main camera because that is really for rendering like 3D graphics on the canvas and such, but we don't need that for Vuforia. Well, we need that, but we need a version that is going to allow Vuforia to use our webcam at the same time, which is a little bit complicated to explain, so I'll just do it. I removed my main camera, and inside of the Vuforia folder, there should be a prefab for the AR camera right here. So I'm going to drag and drop this, and here you go. Now you have another camera actually, but this one is going to include your webcam in it. Now, it needs a few settings before we actually get started. We need the app license key, which you can find on the website. If we just head back to our website, where exactly is my tab? I've pretty much just closed it, so I'll go back. and we're going to head over to develop. Actually, not develop. We're gonna head over to yeah, actually, it's develop. You're gonna find a project that you want to attach this to, or you're going to create a new project. If you want to create a new project, you just go ahead and add a license key. It's really easy to do, and the website is going to take you through the whole process. Now, the mine is already created. It's called AR Lego, and here is my key. I'll be taking this key and pasting it right inside of this field here in Unity. So with this information, I can at least verify that my app is on the website, and they're going to allow me to use my webcam. However, I'm not allowed to use my webcam right now because OBS is actually using it to stream. So what I'll do is I'll quickly just close OBS real quick. That's my streaming software. I'll close it real quick, and I'll just boot Unity first, make sure my webcam is actually being used by Unity, and then I'll come back real quick. And we should be back, I believe. Right now my webcam is inside of Unity, as you can tell. It's upside down, but still, at least it's working in the game scene. And also, it should be working in the scene view as well. So here I am in full screen. Isn't that great? Speaking to you through the Unity client. Right now we've set up our... pretty much already set up our client side. What we're going to be doing next is we're going to be adding the tracking image. So this thing, we are going to be adding it to the database. Now, I have an image like this on my computer. In fact, that's the image I've printed from. So I'll be using it in on their actual website. So I'll head over to the library, create a new database for my new project. Oh, actually, it's not library, my bad. It is under, I believe, tools. Oh, actually, I have no clue. Maybe under develop. Yeah, it's under develop. So under develop, you're going to choose target manager. And then I've already got some database here. I'm going to create a new one. This one is going to be for the Lego game. And it's going to be, it could be on the cloud, but I'll just keep it local right now. I'll just keep it inside of the device. So create that database, go in here, and we are going to add a new tracking image. Find your file on your computer. Mine is somewhere here, I believe. Saved it as a JPEG, and the name is gonna be my AR target or my Lego base. I'll just call it base in this case, because I'll be using this at the very bottom of my Lego structure. Then we just need to wait a little bit, and once this is done processing, we should now be able to see it and see also the rating that they gave your image. So it's still processing. Going to force it now and just see if they uploaded. Okay, so it's a 5-star target and it's currently active. If we go on it, you can see that's your image, and if you can even see the feature of your image, what exactly they're tracking. Now on the screen, you're gonna see like a little crosshair popping up. That's your features. So with this, we should actually be able to start tracking right away, and I think that's what we're gonna be doing. Instead of doing like the mechanic like we've done last time, we're gonna go ahead and just track this image. Also try to flip our upside down camera. It's starting to annoy me quite a lot. So when I show this to my webcam, I want to have a behavior out of it. To do this, we need to make sure our database is actually loaded on our project. Okay, so no target defined. It's still not able to find my target. Let's go ahead and just hit that button and see where it takes us. Takes us to the target manager. Okay. I have plenty of target too, so let's do something. Let's go ahead and just go under our game here, actually our target database, so Lego, and we're going to download that database. Oh, sorry, did I download that as a SDK? Yeah, so let's download it for Unity Editor. Now double click on that, we are going to have some predefined field up here. Database is going to be Lego, and the base target is going to be our image. So at least we get this working now. As far as the database default, oh, there it is. Okay, so all I needed to do was to import the SDK of my database. So I have this now. We're going to hit load Lego database, also active it. And with this, we should now be able to track this thing. I don't know if it does the tracking just yet. So it says something in the chat down there. It says found. That's pretty good. We're also going to just put my face in a different scaling. Let's go for portrait, or actually landscape. So what else do we need to do on this to make sure it's fine? Might as well place my camera somewhere else that I can always look at the object. Now, I don't really have a lot of place here in this office. It's a really small office. But we'll try something out. Maybe like this. Might give it a try like that. Okay, so technically it should be able to pick it up quite good. Now we just have some issues when it comes down to finding that object. So what if I hit load target first? And I delete that image target. Creates image target with value ID. Okay, so it created it some way, I assume. This is it right here. It's actually hidden, you can't see it, but it's the base target. That's the image we've put on the website. So if I don't create it, it just does it. It creates another game object. So might as well just have it on my side here. Might as well just have it defined already. So I don't think I need to touch this anymore, and I can actually just say to test it out, I'll be having a cube on top of it. Right on this side. This is only for testing purpose. And now doesn't seem to have any cube anywhere, but it says it found a trackable object. However, that trackable object was lost. We need to make sure it finds it again. So let's optimize quality to make sure it's not, it's not our asset being too weird of a shape. I don't know if I need to initialize it. We'll give that a try as well. And there we go. Okay, so it took a while, but we finally got it. So the object database has to be initialized, activated. And here we go. And it's really good tracking image. As you can tell, it fits so perfectly with everything. And the thing you see here, the cube, is actually the lighting of the game. It's not the lighting, it's not the image being a little bit messed up, it's just the lighting of the game. And I'm really glad how this turned out. This image is really good for tracking. Unlike the cards I've used in, unlike the actual cards, the playing cards I've used in the past, this one really has really smooth movement. Okay, so next thing we need to do at this point, we need to make sure that this image is pretty much just the center of our world at this point. So let's build on top of it, right? Our Lego game is going to be a big plane. Our floor is going to be a big plane on top of that image target. So right now, I will simply create a cube, have a size in Y of 0.1, something really slim. And then let's just say it's going to be 10 by 10 in terms of size. So 5 on each side. And let's see where this leads us in terms of the engine. Now, obviously, we don't see anything in the game. Well, I mean, we only see the floor. And that's fine. But we're going to change. We're going to need. We're going to need to change our coordinate system, and we do that on the AR camera itself. Now, the world center mode has to be a bit different. We're going to be choosing exactly what is going to be the center of the world. What I feel like doing is just setting a specific target. The specific target is going to be this one, so that's the base, the foundation. Or base target in this case. And then the cube beneath it is the foundation. We drag and drop our base target in there. That's a image target behavior, so we can use it. And then what happened at this point? Alright, going to get up. I don't really have a lot of space to move around since I have these earphones, but let's actually just try taking this webcam. And do we have any result on that? Can we actually see it well? Okay, this is really hard to use since it's upside down. Let's just go with the normal. Okay, so here it is. That's my floor. And like I said, it's really hard to actually see because it's upside down. What if I flip this upside down? Oh yeah, that's way better for me at least. Okay, so sorry about the microphone. This thing is going to be our floor. It's a little bit too big right now. We can reduce the size to say 5 by 5, so 5 meter by 5 meters. And that's what we're going to be doing, so I'll just be leaving it where it is. And we'll modify the scale for a 5 by 5. Just like that, it's a little bit smaller. Hey, the unit maker, we are making a Lego game in augmented reality. The image target you saw a little bit earlier is gonna be our floor, and when we look at this thing, when we look at this target, we are going to just place block on top of that. And in real life, we can move around, we can press, say, at a certain position, it's going to spawn the block. Just some kind of building stuff, just having fun, basically. And I will be right back real quick. I gotta go blow my nose. I'm still having a nasty cold. Sorry about that. Alright, I'm back. Hey Soccer Mustang, yes, this stream is going to be public on YouTube afterward. I might have to do a little bit of editing because I looked stupid earlier, but yeah, I'll actually put that on YouTube. Hopefully we can just have some kind of VR game going on as a stream. Okay, so we have our foundation. Our foundation is pretty much the center of the world. I'm going to go back and just grab some code we've done last stream actually. So let's head over to, where is it at? It should be under here, say AR Lego. We had a script called Game Manager. I'll be opening that in my Sublime text. So that's what we've done last episode. And it was almost working. We've had some confusion when it came down to the array, the block array, but overall it was working fine, so I think I'll just be implementing that super quick, and we can start having some mechanic down as soon as possible. Also, this foundation here, I'll actually put the scale to 0. I don't really have, I don't really want a cube actually. I want to have a plane, so instead of just putting that on 0, let's create a plane. Let's not be lazy. So children of base target, and it's going to be by default it is a 10 by 10 plane, I believe. So 1, 2, 3, 4, 5. Yeah, it's a actually is it 8 by 8? No, it's a 10 by 10. So to reduce it to our size we are going to be going 0.5 and 0.5. 1 in Y is perfect, we don't need to change that. The mesh collider is going to go away, we're going to have a box collider instead. Because we don't want to have like every single vertex act as a collision mesh vertex. A box collider is going to fit just fine for us. And we're going to start scripting a bit. Let's make sure this is our foundation, by the way. Right next to it, I will create another game object. This one is going to be a game manager, like we tend to do in the channel. Let's also create a script for that game manager that we're going to just put on top. And yeah, let's get right into scripting a bit. I've been scripting PHP all morning, so hopefully I don't make any weird mistake. If I do, I'm on a stream, so I'll look stupid. Good times. Alright, so where are we going to get started? Let's start by just getting our foundation object. So I'll be storing it somewhere in a private game object, foundation object. Now remember, when I say foundation, I'm talking about the actual plane that we've just created. So in the start, I'll get it by name. Let's not complicate things too much. GameObject.find. We're finding the object. The name was, I believe, foundation. Like this. Let's make sure. Copy that. And here it is. Okay, so we've got our object. That's pretty good. After that, we're gonna need a offset. Because the center of foundation is actually the center of the world, and we don't really want that since we're gonna be using raycast. You'll see why I do that in a moment. Or you probably already saw why I did that in the last stream. So private vector3 block offset is equal to a new vector3, and also another offset vector3. This one is gonna be the foundation center is also equal to a new vector3, and the foundation center is 5. Is it 5? It's actually 2.5, I believe, in our case. And 2.5 on this axis as well. Now the block offset is 0.5, 0.5, 0.5, and I'll explain that in a second. So we're going to be using standard Unity block, but the problem with Unity block is when you create one, this is what they give you. This is a 1x1 block. This is exactly what we want in terms of size, so we'll just play with a you know, for right now we only have the possibility to have 5 cubes lined up. The size is fine, however the pivot point of this is actually in the center, and that bothers me quite a lot. If the center, if it's in the center, we always have to offset it somewhere else, because say when we're going to be positioning this, we're not going to say, okay, so your position is going to equal to 2.5, 0, 2.5. If we do that, we end up being, you know, out of the chart. So we got to give it an offset, in this case 0, 0.5 on all axis, and you end up with something like this. So let's head back to our code. 0.5, 0.5, 0.5, that's pretty good. Our offsets are there, the game object is there. We can start actually creating our function, our update function. So private void update. Let me just check if we have any messages. Yes, that is of course, that is great, of course. let's move on to the update. We said we're gonna be doing some raycasts. I'm still down to do raycasts. I mean, I don't think raycasts are too much of a problem in this case, since they're only when we press on a button. They're not something continuous. If we were to do a raycast in a update loop without having our if statement, then yes, it would be a really big problem, because we're building for mobile, remember. So mobile games, you don't want to be running raycasts all the time. It's gonna burn out your phone. It's just going to kill the battery. It's gonna do plenty of bad things. So make sure that whenever you make a mobile game and you have some raycasting there, make sure they're really small raycasts and that you don't do more than, say, 3 per frames. Maybe less than that or more, depending on which kind of phone you have. Anyway, physics.raycast, we're casting a ray starting from the camera main position. So camera.main screen point array is a function that is going to take our screen space, our screen space mouse direction and turn it into some real actual coordinate in the world. So here's a function. It's a raycast from where I said, so from the front of the camera to wherever we are clicking on the screen. The raycast measures 30 meters. So make sure you're not 30 meters away from your target in real life. That should not be the case. And we're going to be storing the information of that raycast inside of the hit field. Now, what are we going to do at this point? At this point, let's just instantiate a cube. How do we go about instantiating a cube? Well, we're going to need a prefab for this, because our cube might be a little bit different in the future. So here's what I'm going to be doing. We are going to create a cube, normal cube. I have one right here. I'll just be keeping that one. Position it at the center of the world, so 0, 0, 0. And then after that, you want to be leaving the collider on. That's really important. And you're going to call this something else. In my case, I'll be calling this a block. Drag and drop this in my folder somewhere. Now I can remove it. Back to my code, we are going to go at the top, public game object, block prefab. You pretty much guessed it. We are going to go back to our game manager, drag and drop our block prefab in its public field. However, we can't do that right now because we have an error in the code. I'm going to comment this out. Go back. Now it compiles. Now it has a public field. We can drag and drop our block prefab in here. And wait, did I call this game manager? It's a... my bad. It's a game object. Oh, what is this sound? Thanks, Unit Maker, for following. Alright, just give me a second, I'll finish this and I'll read your comment in a minute. Just to make sure I stay on track. And, okay, so back to this. We have our block in the block prefab. We can now instantiate it at, say, the hit position for now. Just for testing purpose, let's go ahead and just instantiate a block prefab. We are going to store it inside the game object geo. Why not? So instantiate as a game object, and then move that geo, so geo that transform that position, move it to the colliding point, wherever you're clicking. So hit that point, it's going to do the job here. Let's give this a try. And, oh yeah, I gotta be putting this somewhere. Okay, it's a bit weird right now, but I'm clicking and I'm instantiating cubes. That's the start. Also, I need to find a place where I can actually have my camera, but really far away from my target. Because right now, as you can tell, it's way too close. If I move it back though, if I put it on my actual screen, is that going to work? It's a little bit better, but it's still very, very big. Just to give you an idea here, I'll turn off my foundation. It's definitely way too big. So we'll have to play with these settings a bit, but you know, hey, we've just created a something. There's no real name for this thing, but we've just created it. Good times. Alright, let's read that question really quickly. Suggested topic, yes, of course. Yeah, of course you can sub. Just go ahead and leave a comment here or leave a comment on the videos. However, we have more chances of me reading it right now on the stream. So just go ahead and leave a suggestion, and I'll see what I can do. Actually, there's quite a lot of stuff to do on the channel. A lot of suggestion I have to go through, but sometimes some ideas stand out more than the other, and people tend to enjoy those. So I try and put them in priority. Alright, so back to our game, we can now instantiate objects. That's cool, but they have like really weird positioning. So what I felt like doing in last time we actually tried making this game, is I've had a 3-dimension array, and we were just placing things in that 3-dimension array, but it didn't really work out too much. I feel like trying a new approach with that 3D array, but I might actually end up failing, but please just bear with me. I am going to try it. So public, right now it's going to be a public block array again. So let's declare a block class, public class block. It's going to contain a transform. That's the only thing it's going to contain right now. Later on, I wanted to actually contain a color, maybe a different type of cube, maybe like, some water cube, and it would have some physics and particles raining down from it. I have a lot of good ideas sometimes. Well, in my head they're good ideas, but you might think this is plain stupid. Anyway, I'll do my my plain stupid ideas on my side, and you can watch me if you want. So we're creating a new array of blocks, a 3-dimensional array. So let's create it in C#. Thank you. And for right now, we are going to keep it very small, so 5 by 5, and in height we're gonna go up to 5. Very original. So there ain't a lot of cubes you can put on there. For now, of course. Once we actually figure out the whole scaling and we have like proper camera positioning, then we might be able to scale this up to say 10 by 10 by 15. So that's our block array. We have our block prefab. Let's go ahead and just start thinking about instantiating those cubes and just putting them in the array right away. I've had something very cool working last episode. It was a little algorithm that would tell me exactly where you should be in the array based on where you click. So I think I'll just be copying this over. Let's try that. Private vector 3 block position. It gave me the position in the array, so it would cast this as an int and just return me those 3 ints, x, y, and z. And I think that's pretty much it for the array. I'll just leave it there for a second. So that's something we've made. And also we're going to have another function for the positioning of those blocks. So private void position block. And I know I'm doing things in a weird order, but still, in the end, it always works. And I always have to backtrack a bit. So position block is going to be a function that we're gonna feed. You're gonna feed a block to that function. Actually, you don't even have to feed a block. Let's just feed a transform. You're going to feed a transform, then it's going to position it based on the index. Now, index is not a position. I have to remind you that index is not going to be a position. It's really just going to be those number. You should cast those as an int, and then you can access the good block in the array of blocks. This one. Coding on the fly is a little bit complicated because I didn't really write down anything prior. I mean, I have the whole code we've done, but it was a little bit glitchy. So let's try this out. So foundation object dot transform dot position minus foundation center. Okay, going to leave it like that just for now. And we're gonna head back up here. Let's get the index where this block should go. So vector 3 index, block position, hit that point. And now that I'm thinking about it, we are we're just gonna be creating that super fast. And if we have to work on it later on, if we have to just put some duct tape, we will. But now let's just have something working. I like when things are working. Then we can work on improving them, because code is iterative, which means to achieve perfection, you gotta keep doing it over and over and over again. What's that? And Chen Guy, thanks for following, man. So, with those blocks, if we have no block at the position we're actually clicking, it means, oh, by the way, this X, Y, and Z is actually my index. If we have no block at those position, we're gonna go ahead and just spawn one. But right now, let's make sure we have something in those values. If you guys have a second, by the way, tell me how the sound is. I'm using a new setup, a new microphone for this. It's not the microphone I'll be using for my videos on YouTube. However, it's working quite well for streaming, I think. Plus, I can actually hear some music while I do that, which is something I've always wanted while I was streaming. And if you're curious, the music is actually from Position Music. It's a website that pretty much gives me music I can use in my YouTube videos. Okay, so let's get back to the point. If there is no cube here, if there is no cube at the position we're trying to spawn a cube, we're gonna use that array and assign it. So we're gonna say, okay, you're creating a new block. The new block transform is equal to geo.transform. Transform is equal to, did I call it transform for real? Yes, I did. Let's call this block transform so I don't get confused. Block transform is going to equal to geo.transform, and that's all we need in there. Should be fine. And later on we can add some other fields, such as, okay, so the color you had while you instantiate this, so color would be equal to X and something like that. And let's say that there's already a cube where you're trying to spawn a cube. Well, first, let's make sure that you don't actually instantiate one. I was about to do something like destroy geo to remove the game object, but that's a little bit stupid. You know what? Let's just take this and put it inside of the if statement. So we never really instantiate it if we're at the wrong place. Now, if this happens, it means that we've clicked inside of a cube, which is kind of weird. Error clicking inside of a cube at position. And we'll do plus index toString. Okay, a bit of code here. We're gonna try this out. So again, really awful placement on my side. I feel like making this way smaller, but let's try. We get a out of range exception right away. Why is that? Okay, so obviously the hit point is not fine. I have a feeling I know why. It's because the hit point might give you some negative values. Let me just try to actually fix this. And the way I'll fix this is by moving, you know, this base target, the base of the world, really. I will be moving it over to 5. Or should I be moving the foundation only? I'll be moving it to 2.5 in X and 2.5 in Z. So we end up with something like that. Now I might also want to move the base target instead. That's a bit weird what I'm doing here. Well, I'll give it a try. Okay, so we end up with something like this. Let's go back, put that on 0, listen to my first idea, and actually move the base target itself. See if we can actually deal with this now. So in terms of the world, our foundation is still is at the right place. So over here is -1 in X, over here is -1 in Y, so this is 0, 0, technically. if we were to click on this side here on this thing, then we should be able to instantiate the cube at 0, 0. Now technically it would be on this side and it would be right here. Let's have a look. We have a problem with the offset, but still, we got something working a bit. Now, what we would need with this is the other offset, the block offset, which is 0.5, 0.5 on both axes, just like this. And how do we go about adding this? I don't know, we'll find it out. Oh, I think we do that here, position block. We have a function for this, let's actually use it. That'd be cool. In terms of positioning, where do we instantiate this? Am I stupid or I forgot to actually position this thing? I think I am quite stupid. So what I saw was just something positioned at 0, 0, 0 by default. Okay, yeah, I am stupid. That works. Good times. Once we deal with the size, we can actually create some kind of little maze in here. So that's our block. Pretty cool. I'm really feeling like moving this camera right now, actually, just to have some better result. But let's quickly look at what you've wrote. I can't actually see it, so I'll have to head over to the Twitch chat. Okay, so a random generated road in 2D. That sounds like quite a fun, actually. Like the one in Hill Climb Racing. I've never heard of that. So Hill Climb Racing, I'm googling it right now as we speak. Okay, I know what this is. Yeah, we could definitely do that. What I'm seeing in this is not too complicated. I think we could just simply do a curve and add some kind of seating to it, some kind of, I think we can do it. I'll actually write it down and we can, I'll do some research. And I'll be posting something to the channel as a single video with this. I think this is a good idea. There's also another idea that was suggested to me yesterday, or 2 days ago actually. It was to visualize sound, so I'll be able to do that. What you could even do is maybe make a game with a terrain like this that is based off sound, of say a song. And as you progress, that would be the whole song would be already printed out. And as you progress, you just play the sound, the actual sound file. That could be cool. So, written that down. I'll definitely have a check, and I'll come back to you. Well, I won't really come back to you unless you tune in again in the stream. I'll just post some updates on Facebook about it. Great, so again, I'll be right back. I have to go blow my nose. Nasty cold, still there. Sorry about that. Alright. I'm trying to find a way to actually move that camera around without breaking my whole setup. I've got a bit more wire now, but it's still not the best thing. What I could do is just take that thing and throw it on the floor. What about that? There we go, it's on the floor now. Can I detect it, or is the lighting too bad? I gotta get creative here. AR is so much easier with an actual phone. have really hard time making this work on the webcam because of the autofocus, as you can tell right now. This thing is one of the most annoying thing. It should actually work right now. Alright, let's try. Alright. If it doesn't want to work, I don't care. I'm really wondering to which extent we're going to be able to see this. Like right now, it seems not to be able to pick it up too much. Without the fact that it's upside down. Okay. Enough testing for that. We'll have to test it out with an actual phone. What I feel like doing is disabling that really annoying mesh, the foundation mesh. It's still going to be there as a collider, but I'm not going to be able to see it. And the cubes are one by one. They just feel so much bigger for some reason. Oh well. That's gonna be for another episode. That's gonna be for another, once I figure out how to make this look fine. And have some good tracking, I'll make another stream about it. Why is this so big? I'm definitely doing something wrong. Oh, what if we actually modify the scale of our base target? If the width of this is, say, 5, what is that going to give us? I feel like this is worse. Okay, let's try with 0.2. Okay. When you spawn something now, it just looks really weird. Yeah, okay. So let's forget about the idea of making this smaller for now. I'll figure out something. I see that other people are doing it and it looks good, so I'll just have to find out how, and when I do, I'll definitely just make another episode about this. Now, what could we do to make our game better at this point? Except pretty much everything. Let's just make sure our function works. Let's just make sure the little code we wrote earlier work. So I'll be trying it as best as I can. This seems cool. Now if I want to stack on top of it, seems to work as well if I want to stack. Let's click here. Let's try every single side. So this is the top side, say. This one doesn't work, so we're clicking inside the cube and it doesn't seem to work. Let's move on. This side also doesn't work. The top side works, that's cool. Technically the bottom side would not work if we follow that same logic. So there are still a few things to be doing here. Okay, so going with that logic, it means that every negative of a axis is not going to work in this case. Let's find out why. Now this problem we only get it when we click on the cube, I assume, because if you click on every single tile here, I don't believe that if you just click on the floor you're going to have a problem. You really have to click on a cube. Oh. Testing out stuff, guys. Takes 2 hands. There we go, we filled it. Yeah, so 0 problem coming from that. Which means we are going to go with the logic we've had last time we tried this out. We were using a bit flag, which was quite useful actually. A public enum block collision, and it would actually test where it is we're clicking on the cube. So this is under system because we're using flags. So using system, this is a flags, and gotta write it right. And we had few flags. So left was equal to 1, right was equal to 2, forward equal to 4, backward is equal to 8, up 16, and down 32. Because we're using bits here, so we're just toggling on and off a single integer. So that's why we have some offset going on. So that's pretty cool. Now we were using this in the update function when we clicked on something, and that something, it was, the object you click on, it was a block. Now how did we actually get that block is what I forgot. Okay, so we'll do a check here. This is the block position, blah blah. Everything seems to be working cool now. I'll just do an if statement before that. If hit dot game object, okay, so transform dot game object is equal to the foundation plane. If we're actually hitting the foundation object, let's do something real specific. Let's actually look at where we've hit. So vector3 block position is going to equal hit the transform dot position, the place we actually hit. Actually, the object we've hit. So in this case, it would be a block. It doesn't. I mean, there's only 2 things you can hit. You can either hit the collision plane or a block. Okay, I put that in the wrong order. Cool. If we're not hitting the foundation object, we're hitting a block. Let's put that in comment. Hitting a block. Now, if we're hitting that block, we are going to declare a block position. Let's just make sure it's equal to 0 for now. We can actually do that. Apparently, it's possible. Block position is not found. Oh, block collision. My bad. Block collision C. And now I'm going to copy over what I've added. It's a simple if-else if statement. And if we just go over it really quickly, it takes your hit position wherever you're clicking. It takes that position, and it's going to do minus the same axis for the cube. Now, if the difference in between your x, your hit.point.x, and your block position.x is 0.5, it means you're either clicking on the left side or the right side. If it's down or up, it would be on the z. It would be on the y-axis, and if it's forward, backward, it would be on the z-axis. But it's always 0.5 because the size of our cube is 1 meter, and we're always, the cube position is always in the center. So with this, we're able to know where exactly you're hitting. Now, having this logic, we can change our index manually, I think. I think. I'm not sure. Just give me a second here. Wouldn't it be easier to get the normal of the face and use that to know what side you've clicked? Yes, it would be way easier, but I didn't think about that then. Yeah, you're right, we could actually do that. And in fact, we don't even need, if we do the normal thing, since we get a normalized vector, we already have the position of the other block at that time. Thank you so much. This is going to help save a lot of time. That is so brilliant. Okay, so removing all of that crap. If we hit the block, let's just store normal for now. So the index is the hit dot point. Okay, let's leave it like that. So if we're clicking inside of a weird cube here, we're going to declare a vector3. Normal of that cube is going to equal hit.point plus hit.normal. This is literally the new position of, this is going to be the position of the new cube. Now I know how to position this, I just need to know how to actually put it inside of my array, and if I need to put it in my array. At this point I don't even know if I have to put it in my array. Okay, so let's try something like position block. We're taking the transform we create. In this case, let's create a transform. We position it at normal. I'll try something out here. New index is equal to, say, block position and the hit is going to be the normal place plus the normal. Oh, sorry, the usual point plus the normal. New index. Okay, so it's a little bit of spaghetti code, but we are going to get through that, I believe it. Let's give it a try. So this side works, that's the right side, of course. The bottom side, not bottom, but the backward side works as well. Left side works. And is that up? Yep. All side works now using the simple code. Thanks so much for the idea of having the normal. It would be sometimes when you're like, I'm not really under heat, but when I'm streaming, I tend to forget these easy things, and you just had a great idea, you shared it, and I'm glad that you did. Thank you. Alright, let's do some final testing before I go do some research on my own. We've tested pretty much all the sides. Now let's try with the up and not the down, because we can't look at our target from this side. It just doesn't work. Okay, so up and down. This seems to be cool here. Building on top of it. Oh, you know what? Let's do a small castle, since we want to do something creative before the end. We're gonna do a small castle, adding some ramparts. Oops. Yeah, this is annoying. I need to fix the scaling ASAP. That's what I'll be researching on when I bounce. Okay, so we've got this. Let's do a rampart a small bump every 3. This one here. This is harder to control than it looks like. Oh, did I mess up? Okay, no I didn't. That's cool. Here we go, we made a castle. Good times. Yeah, I could actually have a similar picture on the backside. In fact, I have I have some more here. I'm going to show you. Well, in fact, I have to move this to show you things. Can I see the AR camera? Here it is. I'm not sponsored by SteelSeries, but they make pretty good mouse pads. Okay, I'm on the right side too. Okay, cool. So I do have this. This is the image we're looking at. Apparently it moves around with my camera. Okay, I don't want this to happen. Great. But I also have some others that I made, or I printed out at least. So if I was to actually copy this on the same side, if I was to print on both sides, I think I would be able to achieve something. Let's say we're gonna go on the base target, disable the renderer for this, and I'll just click to spawn a cube. I thought I disabled this. Why is this still visible? Okay, so even disabled, this thing is going to spawn if it's in the image target. It's good to know. Yeah, okay. Nice. Now if I just go ahead and try to flip this around, super slowly. Yeah, no, it's still going to take the other side around. It's going to flip it back on the normal side. Let's try multi-target before we leave, because that's a comment I see quite often on the other AR video. So multi-target, I think it's super easy to do. I'm not quite sure how it's achieved, but I saw settings earlier as I was working with this that could help us achieve a multi-target. It was under the AR camera, and all we really had to do was a setting down here, if I remember correctly. Let's change the optimize to default, why not? So where is our multi-targeting? I'll do a Google search. So it is possible, of course. Documentation seems to be gone though. Kinda sucks. Oh, there is a good thread about it here. Okay, so max simultaneous targets, and that would be, I think it's directly on the AR. Oh, there it is. That's like the easiest settings. Right, so let's do 2 maximum. And is there 2 times the same? Okay, so track image and object. Right, I'll just leave it on 2 for both of those. Let's go in the game, see if we can have 2 different things going on. This one works. This one I'm not sure what it's going to do. In fact, I might have to create another base target in that case, and I'll do that, I don't mind. This is base target 1, and this would be base target 2. And they should have different behavior on each side. And things out of range. Okay, so I think it's kind of fighting. When I'm spawning things on this one, it goes on the other one. Well, first, it's fighting because it's fetching a single foundation, so that is quite normal. It doesn't work. We'll try by adding, say, a sphere on top of this guy. Base target 1. Okay, so the sphere works, obviously. However, it has problem just because we don't have like different image, we have the same images. I need something else to actually track this, and to give it a try right now, what I feel like doing is going inside of the target manager. I'm going to go in Photoshop as well, super quickly, and do say a image that is 500 by 250 in height. And let me just grab, if I go back on my desktop, I'll just grab this AR target and split it in two. So we'll have two different images. The small one and the bigger one. This is only for testing purpose, by the way. I'm pretty much done with what I wanted to do for this session at least. But we're just learning a little bit more with AR right now. Half target, why not? Let's head over to the Vuforia website, where I'm going to add my half target. And I think I saved this as a PNG, and they don't seem to like PNG too much, so we'll give it a try. Oh, and they did accept it. Okay. So as you can tell, half target isn't as good because it has less feature on it. It has less detection feature, so it's quoted as a 3 stars. But I think we'll be able to have it working on our side. Right. Let's head over here. Press on play. We have two targets now. We have the one for the game, that would be this target, and the base target one would be using the other half target that we don't have in our game, but because we have to import it. Right, let's go back here, download the database, open it, and re-import everything. This is now a half target. Right. Technically, I should not be able to see this thing, but I am, and the reason is half target is part of the first one. Okay, let's do something here. Let's try to bend one of my target, and it was bent on the half, so let's do it something like that. So there we go, it just detected my half target. Now what about this full one? I have both target that are working. Doesn't seem like it because the first one takes all the place, but if I just disable the mesh render of this spawning cube, move this around, as you can tell, we do now have multi-targeting. And if I just drop this, I feel like it's going to spawn a sphere in this guy, and I don't want that, but still. Well, that's actually pretty much it, and we can go and build our castle again. We can do a lot of things actually. Oops. The possibilities are endless, and let's just put the sphere right in it for the best game of 2015, 16, almost 17 actually. I'm looking for my sphere right now. Where's my sphere? Okay. You know what? By the next episode, I should be able to have a camera that is on the good side. That would be such a good step for me to take right now. Anyway, guys, this is going to be pretty much it for this stream, this first episode of us trying to make a Lego game using some paper actually. And there we go, we put our sphere inside our castle thing, at least, kind of. Let's see. Oh, it's a bit better this way. Gotta be careful because when I put this paper on top of the other one, it loses the first target, and then we end up with nothing. Alright guys, so this is where I will end today's stream. Actually, I won't really end it, but I'll end the recording I'll still be on for some question and maybe chill, play a bit of games, develop my website a bit, all that kind of stuff. So thanks so much for watching. Tune in for the next one where we are going to be fixing a lot of problems we have with the AR right now. Hopefully, I didn't bother you. I didn't. How do I say that? Bore you too much. That's what I'm trying to say. Hopefully, I didn't bore you too much. And we're gonna do something with that game. I believe we have some good ideas. We just need to get the good base going on. And once we have some proper scaling and proper camera direction or camera angle, I think we could have some nice menu going on and actually play Lego in real life. Alright guys, thanks so much for watching. I'll see you again in the next one. Cheers.